Okay, Assalamualaikum warahmatullahi wabarakatuh. And a very good morning from us. So, I'm Hakim and this is Muhammad Asyraf. So, guys, today we want to talk about differential equation, or the short form is DE, yeah. And this is from the subject NTK 3102. And we the lecturer, the doctor's name is Dr. Eliani. Thanks to Dr. Eliani for giving us this assignment and opportunity to make this video. So without wasting any time, so we go straight to my list. So the first slide is my slide is this is my slide. So what is DE actually, guys? So the DE is an equation involving an unknown function in the bracket solution and its derivative. So guys, to be more understanding about this, we can take a look at the next slide.
Hello. Okay, for the second, the properties and characteristic of ordinary differential equation or ODE. The differential equation form, which is y prime plus pxy equal to qx, is called the first order linear differential equation. The first order differential equation that cannot be put in that form above, which is this form, is called nonlinear, because this form only have the y prime and the y which is to the power of 1. So second, when the qx is 0, the differential equation is known as homogeneous. Otherwise, or qx not equal to 0, the differential equation is non-homogeneous. Okay, let's take a look for the examples given. So first, linear and homogeneous. The example is y prime plus 5y equal to 0, because the y is to the power 1 and the equation is equal to 0. The second is linear and non-homogeneous, because the equation is not equal to 0. The third one is non-linear homogeneous, because the y is to the power of 2 or y squared, and the fourth is nonlinear and non-homogeneous, because the y is cubed and the equation is not equal to 0.
Hi guys, we're back. So the third slide, the third point is the solutions of DE. So after I've been searching for past 3 nights, there are only 2 types of solutions. So guys, so first is the general solution and the last is particular solution. So we can take a look at this. So what is general solution? The general solution is a solution that do not have specific value for constant in the equation, which is the constant is called arbitrary constant. I repeat it, the arbitrary constant. So the example, so we can take a look at this example. So this example is quite easy one. So which is the dy over dx equals to c exponent to the power of 2t. So guys, as we can look that this example didn't give the specific value of c. So this is what we call general solution. So I hope you understand this, and of course c can be any real numbers and include all possible solutions. So next, particular solution. Particular solution. Particular solution is unlike general solution, of course, right? So particular solution do produce specific answer or value. So the arbitrary constant is given. Yeah, the difference between particular solution and general solution is the only one is the value of c is given. So we can look at this example. So the example is dy over dx equals to c exponent to the power of 2t, and as we can see, where c equals to 1. So where c equals to 1, of course, the dy dx, the function of the differential is dy over dx is equals to c multiplied by exponent to the power of 2t, and the dy dx is exponent to the power of 2t. So guys, I hope you can understand it, because this is the simplest one. So particular solution can produce an integral curve or one single curve. So next,
Oh, hi. Okay. Come on. Oh, sorry. Okay, the first we can know the methods to solve ordinary differential equation. So the first one, we can use separable variables method. So let's take a look for this one. So dy over dx equal to pxqy. So we separate the variable, which is y variable, to the left hand side and the x to the right hand side. So we get dy over qy equal to px dx. Then we integrate both sides. For example 1, dy over dx is equal to 4y over x bracket y minus 3. So we separate the y variable and x variable, so that we get y minus 3 over y dy equal to 4 over x dx. Then we integrate both sides to get y minus 3 ln absolute y equal to 4 ln absolute x plus c. Then y equal to ln bracket x power 4 y power 3 plus c, and we can simplify to this form, which is a x power 4 y cube equal to exponent to the power of y. So the second method to solve ODE is linear first order equation, or we can say the integrating factor for this method. So as we know, y prime x plus pxy equal to qx is a general form of first order linear differential equation. So from this equation, we will use px to find the integrating factor, like this. So f, which is integrating factor, equal to exponent to the power integrate px dx. The integrating factor, then we can multiply onto the first equation. We multiply to each term. So for this method, let's take a look for example 2. Y prime plus 2y is equal to 0. We know that 2 is our px. So we find the integrating factor f equal to exponent to the power integrate 2 dx. We get the solution of the integrating factor, which is fx equal to e power 2x. Then we multiply to each term on this equation. We get e to the power 2xy prime plus e power 2x 2y is equal to, we can simplify into e to the power 2xy bracket prime is equal to 0. We can simplify and solve so that we can get y x equal to c e to the power negative 2x. Okay, I think that's all for this presentation.
Thank you so much for lending me your ears and eyes. Thank you, doctor. Thank you, and we appreciate it. So I hope you like and subscribe.
Okay, that's all. Thank you.
Thank you.